Hi everyone. Today we are going to discuss about BJT circuit. Here we are considering the NPN transistor and the resistance, which we have considered with the tolerance with plus or minus 10%. We are going to calculate the maximum and minimum voltage across the collector to emitter junction. And here we are considering the collector resistor as a 2.4 kilo ohm, emitter resistance as 10 kilo ohm. Here value of the current gain of the transistor is 100, that is beta equal to 100. If you see the circuit, this is the two supply emitter bias configuration. If we assume base resistance as very small, that is RP is very small, then voltage at the base will be 0 volt, that is VB is equal to 0 volt. That means RB is lesser than beta plus 1 times RE. Then we can say VB is approximately equal to 0 volt. When VB is approximately equal to 0 volt, by the way, here base resistance as 10 kilo ohm, so that emitter resistance RE is approximately equal to 100 times 10 kilo ohm because of the current gain is 100, so that which is equal to 1 milli ohm. By considering this, we can tell base resistance Rb is much lesser than compared to the emitter resistance Re. So let us consider Vb is equal to 0 volt. So Ve is equal to minus Vb, because Vbe is equal to Vb minus V. As Vb is equal to 0, then V is equal to minus Vb. So that value of Vb is equal to minus 776.958 millivolt. And we can assume that the collector current IC is approximately equal to the emitter current IE, because here the value of beta equal to 100. As we know, alpha is equal to beta divided by 1 plus beta, which is equal to 0.99. So it is approximately equal to 1. As you know, IC is equal to alpha times IE, so that we can tell IC is approximately equal to IE. As you know, emitter current flowing in this direction, so that IE is equal to V minus of minus 12 volt divided by 10 kilo ohm, which is equal to 12 minus 0.776 volt divided by 10 kilo ohm, which is equal to 1.1224 milliamps. Here all resistance we have considered with the plus or minus 10%, so that here instead of 10 kilo ohm we can consider I equal to 11.224 divided by Re. Let us consider this as equation 1. Once we know the value of emitter current, which is approximately equal to collector current. If we know the collector current, we can easily find the collector voltage Vc. Voltage Vce is equal to Vc minus V. Vc is equal to plus 12 volt minus IC, collector current IC into RC, collector resistance. And we know Vc is equal to minus 0.776 volt. So that Vc is equal to 12 minus of minus 0.776 volt, which is equal to 12.78 minus IC into RC, and we can call it as equation 2. Earlier we have discussed we have to find the maximum and minimum voltage across the collector to emitter junction. Here Vc is maximum when IC into when IC into RC will be minimum, and VC is minimum when IC into RC will be in maximum. So that VC max is equal to 12.78 minus IC minimum into RC minimum. Similarly, VC minimum is equal to 12.78 minus IC max into RC max. So we need to find the minimum and maximum value of IC and RC. Here we know nominal value of RC is equal to 2.4 kilo ohm. So RC minimum is equal to 2.4 kilo ohm minus 10%, which is equal to 0.9 into 2.4 kilo, which is equal to 2.16 kilo ohm. Similarly, RC max is equal to 2.4k plus 10%, which is equal to 1.1 into 2.4k. So RC maximum is equal to 2.64 kilo. IC is approximately equal to IE, which is equal to 11.224 divided by RE. And also we know that emitter resistance RE is equal to 10 kilo ohm. So that RE minimum equal to 0.9 times 10 kilo ohm, which is equal to 9 kilo ohm. And RE max is equal to 1.1 times 10 kilo ohm, which is equal to 11 kilo ohm. Now we can find the minimum and maximum collector current. 11.224 divided by 11 kilo ohm, which is equal to 1.02 milliamps. And similarly, IC max is equal to 11.224 volt divided by 9 kilo ohm, which is equal to 1.24 milliamps. So that VCE max is equal to 12.78 volt minus 1.02 milliamps into 2.16 kilo ohm, which is equal to 10.58 volt. So VCE minimum is equal to 12.78 volt minus 1.24 milliamps into 2.64 kilo ohm, which is equal to 9.51 volt. Let us verify the current across the collector. So current across the collector is 1.24 milliamps. So that voltage across the collector to emitter is 9.51 volt. When we need to consider VC is maximum, the IC should be minimum and RC should be minimum. Let us verify the collector current 1.01 milliamps. So similarly, voltage across the collector to emitter is 10.59 volt. Hope you have understood how to calculate the collector to emitter voltage when the resistance with tolerance. Also, we have understand what is the relationship between collector current and the emitter resistance. And also, we have understand the how to calculate the alpha value by considering the current gain beta. Thank you for the watching.